So what you just got is a new set of notes 2.8 all the way to 2.15, which finishes Unit 2. But your next test is only 2, 8, 9, 10, 11, and 12. So 2, 8 to 2, 12, the first 5 sections. 2, 13, 14, and 2, 15 will be after Christmas, believe it or not. So let me back up. The first test, that's 2, 8 to 2, what I say, 12, will bring us to exam review. So we'll have our last test, and then we'll have like a week of exam review, and then our exam. Then after the break, you'll still keep these notes in your notebook. To finish up 2, 13, 14, and 15 will be a standalone quiz right at the beginning of January. And then we start our final Unit 3, my favorite, which is Trig. After Unit 3, which is 2 tests also, we'll do exam review. So we're getting there. Don't forget, we did I assigned the progress check on Friday. I gave you time in class to do it. You have until Wednesday midnight. It closes Wednesday. So, Gio, you weren't here. Everyone else that was here, maybe we're working on it. If not, make sure you do. And then on Wednesday, same day that closes, in AP Classroom 2.8, 2.9 will open, and you'll have a full week to work on that. And I also have a work day built into this week. Okay, so Friday this week is a work day, so you could work on this quiz on Friday if you wanted to, in class with your classmates or whatever. Okay? All right, so we're starting 2.8 for 2 days, and 2.9 will be 1 day. So Wednesday we'll finish everything you need to know, and the quiz opens that same day. Okay? So take good notes. It's an open note quiz. You know it's going to, and I'm going to point out places where there's a question on your quiz that's just like this. So good notes will hopefully mean a good quiz. And this is your second quiz. So if you did bad on the first one, you want to do well on this one so it drops it. Okay? All right. So what we're talking about in 2.8 is inverse relations. Okay? So, or inverse functions. Let's get some definitions out of the way. Whether you write them or not is up to you. But this word called relation is going to be used a whole bunch. So I want you guys to know what a relation is. A relation is really simple. It's just a set of ordered pairs. It can be in the form of a table of values, the next Y chart. That is a relation. Any graph, that's a relation. An equation, slope-intercept form, an equation for a quadratic. It's just X's and Y's, okay? So relations are a very generic term, okay? I mean, just a bunch of ordered pairs, okay? A function, the definition of a function, you may think back to Algebra 2, where we would say, like, no repeat X values, or it passes the vertical line test, things like that. We have to be a little bit more specific in this class. Each input, so we know inputs are like X values, has exactly one output. This word exactly is very important. One of the FRQs on your AP exam deals with inverses very specifically. So when we get to that part of the review of the year, we'll really go make sure we memorize, We'll make sure that we really memorize the script of what they want you to answer for certain questions. This is one of those that I graded in the past. I actually had tears over it, story for another day. But it's so specific as how you have to write your answer on the AP exam that I will be teaching you that script so everyone gets it right, okay? But for right now, we're going to be a little bit more casual. So let's read. An inverse relation. Okay, so a relation, and then you do the inverse of it. We'll undo a given relation. Okay, sounds kind of crazy. Every inverse relation can be found by switching each X and Y value. So when we go to find the inverse, all you're doing is switching the X's and Y's. We're going to do it in a table of values. We're going to do it on a graph. We're going to do it with equations, all 3 ways, all right? And in some situations, this process is intuitive, but other times this may not be as obvious. In these cases, it is important that we understand he wants to put concept here, the concept of inverse relations, as they will help us tackle a variety of problems. Okay, so I'll explain that all much better with some examples here. So we're going to look at it numerically, which is tables, graphically, pictures, and analytically, which is equations. Basically, the three types of relations we work with, okay? So here we have a table of values, right? And it's just inputs and outputs, right? And what we're going to do is find the inverse. Watch, this is hard. It's really hard, guys. You switch the x's and y's. Do you need me to do it again slowly? Okay, so you literally switch the x's and y's. That is finding the inverse, okay? Here's a function. We found its inverse by switching the x's and y's, okay? Now, let's take it a step further. The original table is or is not a function, okay? Look at my x values. Each input has exactly one output. And that's true. And sometimes, and this is what made the tears for me one time. I'm kind of a perfectionist, and if I'm struggling with something, it makes me mad, and then it makes me cry. Like I cry when I'm mad. But anyway, so when I was doing this, I hate that definition. So, think about every concept you've ever learned in math, and there's been those days that you've looked around and everyone understands it but you're like, why am I not getting this? And then other days you're like, I don't understand why that girl doesn't understand this, or whatever. We all have our things, right? This language is confusing to me. A function is where there's no repeat x values. Look, all the x values are different. That makes it a function, okay? So this is a function because each input, x value, has exactly one output, okay? However, the inverse, okay, so here's the relation. This is the inverse, right? This guy is the inverse. But is it an inverse function? You can't say that yet. However, the inverse is, I'm going to go ahead and give us the answer, is not a function because and you want to give examples. The x value 2, right, has two different y values, which is 3 and 6. So let's do it like this. The x value 2, right, has two TWO different y values, 3 and 6. So in this case, see how there's repeat x values? You can't use that language at this level. You would say the x value of 2, which one is causing the problem? The x value of 2 has two different y values. Now, I'll be honest with you, today in the homework and stuff, you don't really have to give any definitions. We're just kind of getting introduced to it here, okay? Really, this whole lesson is about, do you know how to find the inverse? Flip the x's and y's, okay? And so we just learned how to do it with the table. The first two homework problems are exactly that. Flip the table. Okay, and there's a quiz question where here's a function, which one, A, B, C, or D, is the inverse? So you just have to flip the x and y values, okay? That's one of your 10 quiz questions. All right, now let's look at it with a graph. So it says to sketch the inverse relation of the given graph. Okay, so here's the given graph. So how do I find the inverse? Well, it's all about the x's and y's, right? So if I made a table of values of these x's and y's, I'm just going to pull off like these 4 main points, okay? Just these 4 main points. And that would be, so -2, -1, -1, 2, 2, 1, and 4, 3, okay? So this is, let's call it f of x, just so we have a name. Let's call it, so we know. Okay, so we'll call that guy f of x. Those are his 4 main points. Okay, so to find the inverse, we're just going to flip them. So switch those x and y values, just like we did above. And let's sketch the graph. So, -1, -2. So, as I graph, I'm going to say those two are a line segment. Those two are going to be connected. because I'm just following what these were. Like these two were connected, these two were connected. And then 1, 2 would be here. Keep going. And 3, 4. 3, 4 would be up here. Now, there's the graph. So this one's a little tougher to talk about if it's a function or not. So is the original relation a function? So this guy right here, you can't always just look at the xy points because remember, in this example, we just picked certain ones, okay? This is where the vertical line test trick does kind of help. If you remember, if a relation is a function, it would pass the vertical line test. Now remember, I'm just looking at the original graph, not my pink graph. As I take my vertical line and cross over it, I don't touch the graph more than once. It is a function. I mean, you could look at the table and say, yeah, look, all the x values are unique and different. There's no repeats of them. So yes, the original is a function. So f of x, which is what we called it, is a function. Is the inverse a function? So here's what I was talking about. If you just look at the xy chart, you can see, oh, you might say, oh yeah, because there's no repeats in those x's, right? But if you do the vertical line test, for example, right here, do you see how we touch the graph in a bunch of different places? Those are all the same x values, okay? So visually sometimes is the easier way of doing it. And so you could say the inverse is not a function. Say it again. I'm going to teach it on the next page. Okay. Yeah, I'm going to give you a notation for it in a second. Now, here's a really fun fact. Whenever you graph a function and its inverse, the graphs will be symmetrical over the line. So, symmetrical over the line of y equals x, which is this line that goes right through the origin. So you should see exactly the same points on either side of that line. Okay? I know mine's kind of a mess. Let me just show you it written, drawn a little nicer. So you can see the y equals x. So when you graph any function in the entire world and its inverse, just like we just did, they should always be exactly left and right, exactly the same, symmetric over the line that goes right through the origin. Okay, that's just a fact, 100% of the time. So that's those guys. All right, next page. So we did tables, we did graphs. The last one we have to talk about is equations. So what we're going to do is find the inverse for an equation. Remember, the steps are switch x and y, except we have to go a little further and solve for y, okay? And we're going to learn a new symbol. Here it is, which means, if the original was in f(x) form, right, let's say, where is it? There. So, I'm just going to call it. I guess it's just blank. But anyway, I'll show you what I mean. Inverse, we always use that little -1 up there. We can say that as f inverse of x or the inverse of f of x. Okay? So, guys, remember, f of x is y, right? Just fancy y. So the first step is to switch x and y. So all I'm going to do is switch x and y, just like we did in the other two forms, but then we just have to get y by itself again, right? You can show some work. You can do some of this work in your head, I'm sure. Divide by 3. And you can leave it as a big fat fraction like this, or you could separate it, okay? So here's how we write the inverse. Would be, you can write it just like this, or x over 3 plus 7 over 3. They mean the same thing, okay? But that is the inverse. If I graphed those, remember, we're not going to. If we graph those, they would be symmetric over that y equals x, okay? Okay, so I guess just fill in the blanks. It's going to bother me if we leave these blanks empty. Okay, so that was a linear equation, right? Pretty simple. Most of you, all of you really don't have to show any work for that, right? Right? Here's where it gets a little trickier, a tiny bit. Do not be intimidated by these problems, especially when they write out all these steps. Don't worry about that. If you need to go back and look at the steps, you can. We're going to do 2 of these, and I gave you 2 in your homework. You should have no problem with these if you do them with me, okay? Because the steps are the same every single time, exactly the same every time that you do these, all right? So find the inverse. Now, these are rational functions. If you remember a poly on top and a poly on bottom, these are the ones that had like poles and HAs and BAs and all kinds of stuff going on. Don't worry, we're not graphing them. We're just going to find its inverse. So, of course, we know that that's y, right? So first step is to switch x and y's. So I would have x equals, and I'll change both of these x's to y's. And what intimidates us sometimes is fractions. Like, oh gosh, another fraction. Why should we give us fractions? But they're not hard to solve, okay? Remember, a fraction is just division. This is division. And I want to get rid of this fraction division. So all I'm going to do is multiply both sides by that denominator. Multiply this side by this side. Now, why do we do that? Well, if you multiply a fraction by its denominator, remember, they cancel. So we just got rid of that gnarly fraction on the right-hand side. And over here, you're multiplying a monomial by a binomial. It's just the distributive property. Just multiply it. xy plus 3x, or you could have written 3x plus xy. Doesn't matter. Okay, so we got rid of the fraction, but now we've got kind of what looks like a mess here. Remember your goal in the end. Switch x and y, solve for y. I need to get y by itself. The problem is I have y's on both sides. So I need to get them both together. It makes sense to bring this y over to this side, right, by subtracting it. Well, then you're going to have to move this 3x over here. So why don't you just switch their places in one step? In other words, I'm going to subtract y from this side, subtract 3x from this side, because I'm just trying to get y by itself. So I would have xy minus y, right, that took care of that, equals, and then I'm going to subtract 3x over here. Could I have written negative 2 minus 3x? Yeah. And how, so I got the 2 terms that contain y on the same side. Does anybody know what I would do as my next step? Factor out your GCF of y. It's like a binomial. They both have a y in common. So you don't have to show this, but you're just dividing both of these by y. Whatever's left over goes in the parentheses. Y divided by y is 1. And there's only one step left. This is just multiplication, right? Opposite of multiplication, division. Divide both sides by x minus 1. So our inverse, let's use our new symbol, is, now I'm going to write this answer 3 different ways. So especially once we do one more of these, you guys will have the steps down since they're exactly the same every time. But what can get confusing is how answers can be written. Like, if this was just like an FRQ on my test, there's 3 different ways you could write it, and I'm going to show you all 3, and they would all be full credit, because they're all right. But what if it's multiple choice, and you have this as your answer, and you see one of the other 2 ways it can be written, and you're like, oh, I must have done something wrong, let me guess, and maybe guess the wrong answer, okay? So I'm going to just rewrite that one. If you don't want to, you don't have to. So this is one way you could see it, perfectly fine. You could also factor out the negative of the numerator, right? That's exactly what that means. And then here's the final one. If you put the negative in the middle, so it's in line with the fraction box, okay, then you would just, you could leave off the parentheses in the numerator, okay? So look at the 3 different ways. Where it was exactly how we got it in our final answer. That negative factored out with parentheses with the negative right in front of the parentheses. We know what that means. Distribute it. Go backwards. Now, if it's put in the middle, it's understood that you would then move it to the numerator and distribute it. We would never leave a negative in a denominator, okay? So if you see a negative in the middle, you would, if you were going to apply it, it would go to the numerator, okay? So any of those would be full credit. And you'll see in my homework, I would write like all the different ways, so you pick which one you like, but just be aware of the differences. Okay? And that only is going to happen if both of them are negative. If one of them's negative or they're both positive, you won't have that issue. All right? Let's do one more. Switch x and y. And solve for y. So, this is division. Let's multiply both sides by that denominator. If you multiply a fraction by its denominator, they cancel. Distribute here. And this is where you gather your thoughts. Okay, I'm supposed to get y by itself on one side. I've got y's on both sides. Oh, right, this is where I switch some things around, right? This 2y is going to come to the left. This negative 3x will come to the right. Factor out the y. Remember, we're just taking a y from both of these. Whatever is left goes in parentheses. Last step, divide both sides by x minus 2. And this was g of x, was the name of this function, so I'm going to use g inverse of x equals 3x plus 1 over x minus 2. Okay? So, 2 of these in your homework following the same exact steps. Of course, I'll help you if you need it. Okay? One last example we have to do, and then we are done, and you should have no problem finishing your homework in class. No problem. Okay. All right. 2 functions, okay? So if we take a function, f of x and g of x, they are inverses of each other if and only if, remember this notation? You put g of x into f of x, put f of x into g of x. So you have to compose g of x into f of x and f of x into g of x, any order. In both situations, your math should resolve down to the letter x. I'll show you what I mean. So to show that 2 functions are inverses, we must show that the compositions both equal x. That's what this is called, composing. G of x into f of x into g of x. Okay? So we are given 2 functions, and we're asked, are they inverses, yes or no? I'm not going to do another example, but another way that it could be asked is show that they are. These 2 are inverses of each other, show us. So you would do exactly what we're doing. Here we're saying yes or no. Okay? So we're going to do g of x into f of x into g of x. It's going to look a little gnarly at first. It's not. It's actually very simple math once I show you. Okay? So we take g of x and plug it into f of x. Here's g of x. Plug it into f of x. Okay? So that would be 2. And then parentheses. So I put all of g of x in there, and don't forget the minus 3. Guys, don't forget, when you multiply a fraction by a denominator, they cancel. So when you do 2 times 1/2, the 2's cancel, and you're left with 1x. We don't write 1 in front of x. We're just going to call that x. Okay? 2 times 3/2, 3. And then there's a minus 3 at the back. So they cancel, left with x. That's what we want to see. We should get x here. If I didn't get an x here, there'd be no reason for me to do this. We should get x when we do both of these. So we're halfway there, okay? Now I'm going to do f of x into g of x. So take all of that, and plug it in our learner. So 1/2 parentheses, put that guy in there, and then plus 3x. Guys, when I distribute 1/2 times 2x, again, you just get x, right? The 2's cancel, you're left with 1x or just x. 1/2 times -3 is just -3/2, right? I just distributed. And then there's a plus 3/2 at the back. Those clearly cancel. We're left with x. So yes, these two are inverses of each other. So we're not going to do it, but if I did g of x into this one, and I did this one into the original, and simplified all that work, I would get x in both places, because these two are inverses of each other. Okay? Here we are being asked, are they inverses of each other? Yes, they are, because we got x, and we simplified. Okay? All right. Yeah. Is that here? All right. On your worksheet, I think I typed B14 at the top for you, but these are the problems. So I gave you pretty easy homework here. Guys, remember, when there's time, like especially like on a work day, if you want to see your test or something, you can. Because there were some mistakes that were really common. Real quick, let me tell you. Limit statements, we were having some problems with. Rounding was big. And what if you did your names backwards? Remember, okay, so guys, don't forget how limit statements have to be written. And if you're not sure if you got it right, you want to see your test or something later, that's fine. But this is exactly how you have to write it. You can't change the order. And I was kind of surprised. I've had to take points off a lot of people's tests because their limit statements weren't right. And guys, we need to know how to round. If you're not understanding how to round at this point, you need to talk to me so I can help you. Okay? Guys, I'm not going to put 1 and 2 up. We're just flipping the charts. Okay? I don't think you need my help. Let's put 5, 15, 7. And I'm going to get this on, almost said Facebook. I'm going to get this on Canvas right away because it's hard to see these keys very well. That's small.